And now we go on to another collaboration. So I'm delighted to introduce you Harm de Vries and Leandro Gruenpeter from ServiceNow and Hugging Face, but I will not do any spoiling. So I wait for your presentation to be ready here, hoping that it works. And by the way, all the source code, which is, maybe I forgot to say, everything we develop for the infrastructure of software heritage is 100% open source. So everything you have seen here can be available, reused for your own application directly if you need it. And it is not just a philosophical point of view. I mean, if you build an infrastructure for long-term preservation of a part of mankind's knowledge, how could you trust us if you used black boxes in developing this kind of technology? If you remember many years ago, I remember in the UK, you had this doomsday exercise. I don't know if there are people old like me that remember, they put everything on a laser disk that had a closed technology, not open standard, etc., saying we put it there, they spent a huge amount of money, and 2 years later, nobody was able to read the disk anymore. Okay, so we do not want to get into that situation at all.
Hello, everyone. My name is Harm de Vries, if you didn't get that. And my colleague Leandro is right next to me. So we've been both co-leading this big code project. And I'll be talking a little bit about that today. For the people who don't know, like the whole generative AI hype and like might have missed out a bit on it, I'm just going to show you an example of like Copilot. It's really like one of those, when I first tried it, right, it's like one of those magical moments where you type in like a function signature and you just have a model that completely produces the function for you. Or in this case, actually, you also have like, you provide the function and you write the model to write unit test. And basically in the chat next to it, you just see that the model can generate a bunch of unit tests for you. So this is really, you know, as a developer, when you start to experience that, it's really a magical moment where you're like, hey, these models are so good and they can really speed up my development process. Yeah, so this was an example of Copilot. And I would say this falls into sort of like the closed model API bucket. So we have like all these amazing models, like from OpenAI, from Google, which they call Gemini, but there's also like Anthropic and the Copilot model. And these are just closed model APIs. So you can only access those models by calling an external API. On the right-hand side, we have what we call like open model weights. And so you might have heard of like Meta, the Llama models. There is Mistral with the Mistral 7B and the Mixtral models. And there are also like a couple of Chinese open source LLMs, among others, like DeepSeek and Yi, which are like really coming up and becoming very strong open source models as well. And yes, that finally works. And so, of course, there has been like a lot of like arguments, like I think a lot of people know why we want to have like open model weights and not closed weights. And so like the most common arguments you're hearing is like, hey, the model weights are not available, so I cannot run these models on my own hardware, right? So I have to trust the party that I'm sending my data to. I can also not inspect what these models are doing. So what are the representations? What are they? How do you actually arrive at the answers? And also I cannot fine tune. I cannot make them more specific to my own use case. On the other hand, so like the open model weights, right? Like they are available, you can run on their hardware, but for all these models I've mentioned, the training data is not disclosed. So for the Llama models, for the Mistral models, you don't know what data went into there. And this has a couple of like downsides. First of all, like if you are a content creator, so if you are a code developer, you don't know if your data was used and there's no way to remove it from the training data. We also cannot expect the data for biases, right? So we might have like social scientists might be interested in investigating like what are the biases of the model, and often you want to look at the training data for that. And as a scientist, right, like for me, it's really important as well to understand how good these models are. We often use a lot of benchmarks, and nowadays we don't even know if the benchmark was part of the training data. So the model might actually look much stronger than it really is. And that's sort of like strengthens the fourth point. In general, like the scientific reproducibility is very limited with these models that I mentioned. Cool. And so like we started this big code collaboration really on this premise of like data transparency, right? So we develop these models while we are completely transparent about where the data is coming from, how we've processed the data, and what kind of training code we've used. And at the same time, we release sort of like all the models we create with a commercially friendly license back to the community. So we started this project in September 2022. So even before the ChatGPT hype started. And in the meantime, so like over 1,100 researchers, engineers, lawyers, policymakers have joined our community and so like contribute to like building these models in an open and responsible way. And Leandro is going to tell you a little bit more about what we've done so far. And I think he also like give you a sneak peek about some new models.
Thanks, Arm. So yeah, if you want to start training a large language models, the first thing that you need to do is you need to create a large data set, which is the foundation of any large language model these days. So the first action item we had when we started Big Code is we need to create a large scale and high quality data set. And here on the left-hand side, you can see sort of our pipeline. This was before we started collaborating with Software Heritage, so we did all the crawling ourselves. We experienced how painful it is, so we're now happy to work with Software Heritage and hand that part over to them. But so what we did is we went to GitHub Archive, which is also an archival effort, and we queried it to get all the repositories that exist on GitHub. That gave us a list of like 200 million GitHub repositories, and then we spent 6 months Git cloning all these repositories, which yielded roughly 100 terabytes of data. This pretty large data set needed to be processed a little bit. So first we filtered file extensions. So we focused mainly on extensions that contain source code. We threw away things like CSV files that are also present on GitHub. And after filtering for these file extensions, we went from 100 terabytes to only 70 terabytes. And then we did an additional step of license filtering where we only filtered for permissively licensed code. And that brought down the number even further. So from those 70 terabytes, we ended up with 6.4 terabytes of permissively licensed code. And at this point, we ran a lot of studies trying to figure out like what makes high quality code for pre-training language models. We want to figure out like we have these 7 terabytes or 6 terabytes of data. What can we do to that data to make it suitable for language model training? And we tried a lot of things. We looked at code to comment ratio in those source files to see like maybe if we only select well-documented code that improves the quality of models. We tried to filter with GitHub stars. In the end, we found out nothing really significantly improved the performance of language models, except one thing, and that's near deduplication. So we already exact deduplicated. So if 2 files are exactly the same, we throw away one of them. But we also threw away near deduplicates, which means if 2 files are almost the same, which happens in code a lot, somebody forks your repository or changes a little config. So you have a lot of files that are almost the same. If you're near deduplicate, that improves the performance a lot. We open source or release both data sets. They're both available on the Hugging Face Hub at the moment, so people can download them. And in addition to that, we also provide a data inspection tool and an opt-out form. So people can check whether they're part of the data set that we use for training. So you can see if your code went into it. And additionally, you can also opt out. So you can provide your GitHub username. And then in the next training cycle, we remove your training data. We remove your data from the training. We can't obviously do it for the models we already trained. With the data set, we call it the stack. We trained the first large model. We call it StarCoder. It's a 15 billion parameter model. It's a little bit like, I would say, middleweight. It's larger than some other language models and smaller than some of the big ones. But we found it's like a good sweet spot of model performance. We trained it with a context window of 8,000 tokens, which means the model can see at maximum kind of 8,000 words when it makes a prediction for the next word, which is important to have enough context to make an accurate prediction. And we then used our cluster with 500 GPUs and trained the StarCoder model for 3-4 weeks on 500 GPUs. You can see on the right-hand side, the loss curve. I'm the chief loss officer, so I'm happy when the loss goes down. And it went down pretty smoothly. There were a few spikes, but we didn't need to do any intervention. And after 4 weeks, we had StarCoder 1. One thing that we found quite inspiring, and I think underlines a lot of the points that have been made in the previous panel as well about open source and sharing research and doing open science, is the ecosystem that evolved around the things that we built. So we released the stack, which is the pre-trained data set. And since we released the stack, virtually every model that has been trained on some code has been using our data set. I listed here a few of the open models that have been released and admitted that they use the stack. There are also some models that are very popular that also use the stack, but don't mention it. In addition to that, not everybody can pre-train their own language models. And a lot of people have used our pre-trained models, so StarCoder, and fine-tuned it on their own data or their own flavor of languages. So there has been a few models like VisitCoder that have been instruction tuned and improved to write better code, or there has been SQL Coder, which is a model specific for SQL code built on top of StarCoder. So we found that kind of like the most inspiring outcome. A lot of people using the tools that we've built to build on top of them. Now I want to give a small sneak peek into StarCoder 2, also to give a little bit of insight why where software heritage comes in here. So we've been working on this for the last 6 months, and some of the models are still training, but we can give you some sneak peek. First of all, we partnered with Software Heritage for the obvious reason that we didn't want to crawl anymore ourselves. And since Software Heritage already does it, and does it probably much better than we did, it makes a lot of sense to use their data set. But on top of that, it also made a lot of sense because our values are very aligned. So last year, Software Heritage put out a statement on like what they see as like responsible use of their data set to train language models. And it came down to roughly 3 things. You should be very transparent about the data that you used. We've already done that with the stack version 1, and now with the identifiers of Software Heritage, we can do that again. The model should be released in an open way so the community can profit from it. We still plan to do this. And there should be an opt-out mechanism. So if people don't want their data to be included in the model training, we can exclude it. And for those reasons, it made a lot of sense to team up. And currently, we built the stack version 2, a larger data set, and we're training StarCoder 2. And here you can see on this bar plot, on the very left side, maybe it's a little bit small, that's StarCoder 1 3B. So it's a small version of StarCoder 1. It got like 20% on a benchmark that we used to evaluate the performance. StarCoder 1 15B was much better than the 3B model. It's bigger. It got 30%. And now for StarCoder 2, we have a 3B model, so a model that's 5 times smaller and matches the performance of StarCoder 1 15B. That's exciting for several reasons. One, it's 5 times smaller, so people can run it on much smaller hardware. 5 times smaller also means it's 5 times faster and 5 times cheaper to run. So I think we're very excited to release those models in probably 1-2 weeks, along with also some larger models that we'll yet to announce. So with that, thanks a lot for your attention. And I think we can either take now some questions or during the coffee break.
Well, thanks a lot, Leandro and Harm, for taking the time to come and showing this just in time for the symposium. It was super exciting for us to be contacted by you more than a year ago. I don't remember, a year and a half, something like this. And we discovered we had this alignment, and we decided to actually work together. It took a lot of time to set up the right principle, to have the agreement signed with your companies and INRIA. This has been done. I'm very grateful for INRIA for helping out with this. And this, I think, is another incredible demonstration of the power of what can happen if we build this common infrastructure and work together to share the result. So I think this is just the beginning of the story. I look forward to work. We look forward to work much longer with you and much deeper on doing these kind of things. And thanks for coming a part of our dreams come true. Thanks a lot for your help. And don't let them go without asking questions during the coffee time, which is now. And we need to go back, come back in 20 minutes. 20 minutes for the coffee break, which is just downstairs. Thanks a lot again.